I am B. Sangeethapriya, working in Department of CSE IoT as an assistant professor in SNS College of Technology. Today, my students are here to explain about CPU scheduling. In operating system, the CPU is the most valuable resources. Introducing the real-life analog, hospital doctors, bank manager, faculty cabinet. Many processes are completed from one CPU. Poor scheduling leads to the delay and the frustrations. Here we will be explaining this concept using our DT framework, like empathizing, decide, ideate, prototype, and test. Now my students will explain.
Now coming to the define part, CPU scheduling is the method an operating system uses to decide which process gets to use a CPU at any given time. Since many programs run simultaneously, but there is usually just one CPU core handling tasks at a time, the system must choose wisely. The goal is to keep the CPU busy, reduce the waiting time, and improve the response time, and also maximize the overall efficiency. Then, there are two main types of scheduling: preemptive and non-preemptive. In the non-preemptive scheduling, once a process starts executing, it continues until it finishes or blocks itself. In the preemptive scheduling, the operating system can interrupt a running process to give the CPU another process, improving responsiveness. So the common algorithms includes the first come first serve, which executes the processes in arrival order. Shortest job first, which selects the process with the smallest execution time, and priority scheduling, which runs higher priority tasks first, and lastly, the round robin, which gives each process a fixed time and slice in rotation. Overall, CPU scheduling ensures fairness, efficiency, and smooth system performance.
The CPU can be scheduling this four kind of process. There are FCFS processor, and then SAS processor, and then property processor, and then round robin processor. The first come first serve processor that is easy to complete the works, and then it is faster. And then FJ processor also can do same kind of process, and then it use disadvantages. It have take more than time, some than long process. And then round robin process, it will be contained more efficient to works, and then it comparatively different to the FCF processors.
Coming to the prototype part, so if we consider multi-user system by implementing the CPU scheduling. CPU scheduling it provides fairness and multitasking efficiency higher in multi-user systems by implementing round-robin kind of algorithms. So what this round-robin algorithm does is it implements a circular queue where the processes are scheduled, and each process is given a time to live duration. So considering a 10 millisecond process which needs 10 milliseconds of time, in this circular queue, it will be allocated 4 milliseconds of time, and then consecutively it will jump back to the end of the circular queue, and it will come back again to the processing state where it will go on and utilize its whole of 10 millisecond time. So by implementing this CPU scheduling in multi-user systems, users utilizing a time-shared CPU will experience low latency in implementing any processor, in implementing any process or running applications.
So I would like to talk about waiting time, turnaround time, and response time. So waiting time is basically about the entry queue, like the process, the time required to start the process. Like turnaround time is a complete whole process completion time, and the response time is the response time per second. So why do we need all this? So basically, CPU is a technique not so cheap one, which we need to preserve by spreading its work and using it efficiently. Well, using it efficiently doesn't mean like proper air conditioning. air conditioning, not just that, equally managing the threads and codes. Like we need to spread the work equally. We can't just dump all the work on a single code. With results in CPU crash. So then we have came across first come first serve, first Robin and priority. These are the main core process which is required to split the work among the CPU.
As the conclusion of this session, we have seen what is CPU scheduling and what are all the algorithms we are using. The main algorithms are first come first serve, shortest job first, and next one is a priority scheduling, and the fourth one is round robin. Hope you all enjoyed this video. Let's see in next video. Thank you.